Okay, so I'm going to talk to you about another way you can combine propositions to make different statements. And we're going to look at something called implications, or um, so we'll look at implications first of all. Right, so if you want to combine two statements together, and if you can combine them in this way, so for example, with the sentence, if something, then something. Okay, so this is what we call an implication, and I'm going to do it with an example, right? So let me just explain with an example because that'll be much easier to do. Right. Let's take the example that everyone's going to go through. Let P be the proposition. I will revise for my exam. Okay? So that's proposition P. I will revise for my exam. True or false? It should really be true. Okay, let's just say that's true. Yeah, but that's a bit of a joke. I don't. Well, it should be true. Right. Q is the statement. I will pass my exam. Okay. Now I can combine these two together with the following words added in, right? Because if underline that, I'm going to just modify this sentence a little bit. Okay. If I revise for my exam, then I will pass my exam. Okay, this is not a very good grammatically correct sentence, but that's not the point here, really. It doesn't matter too much about the grammar in these particular tests or anything like that, but it's this here, if, then. And that's what we call an implication, because if you revise for your exam, then you should pass, right? Then you'll pass. But this is what we call an implication. And this sentence here, I can sort of write in algebraic form, and it'll be P implies Q. Okay, so this is here. This is this red, this thing that I'm circling in red. This is the same thing written in algebraic form. This box in this thing that I'm circling in yellow. Okay, we say this bit here. We say is P implies Q, right? Okay, P implies Q. That's how we say in words. But really, what it means is this sentence here. Okay. Now you can have lots of different implications. You don't have to have things like this. So you could have for something, for example, let's say P was something along the lines of I will eat some cake. Okay, and Q is the statement I will go for a run. Okay, a simple, really simple, easy 2 or 3 mark question would be something like write the following as a sentence. P implies not Q. Okay? Alright, so P implies not Q. Now, you need to remember this. The implication, when you see that, that means if, then. I think, do you get 1 mark for writing that? You get something for having the words if and then written somewhere. So as soon as you see this, that means if, then something else, right? So what is it then? If I eat, let me write this a bit grammatically correct. If I eat some cake, then I will not go for a run. Okay, because that's not Q, right? So this is P implies not Q. Okay, that's really easy to do, but you need to remember that this thing here means if then, and then you write the first thing here and the second thing here. You could literally, I mean, it's not based on grammar, unfortunately. Maybe it should be, but it's not. You can literally copy and paste that thing here, and then stick the word not in here somewhere, and then copy and paste that, even though it doesn't make sense grammatically. It's sort of like a computing type language almost, right? So it doesn't matter too much on the grammar, but when you see that, it means if, then the other. Now, let's look at the truth table behind this. Now, if you don't follow this next example, then just remember the scenario, okay? Remember how it works and stick to that, okay? So kind of just commit to memory. But I'm going to try and explain it with a really, really simple example. Now, let's say there is some club, okay, that you want to go to, okay? This club has a rule, okay? The rule is, okay, let me write it as P implies Q. The rule is this: if, I'm making this up as we go along, so if you are wearing a tie, then you are wearing smart shoes. Okay, now this sentence does not make grammatical sense at the moment, but I'm not too fussed about that. I'm just getting the idea across. Now, what is P and what is Q? Okay, so this is clearly P and this is clearly Q. Now, the words to remember is P implies Q. This thing is called the antecedent, and this is called the consequent. Now, the rule of the club is that if you're wearing a tie, then you are wearing smart shoes, and that's the rule to get in, okay? So if you've got a tie on, you better be wearing smart shoes, and that allows you access to the club. Now, let's look at the truth table behind this, okay? Now, think about all the different scenarios that could happen, right? So we always start the same. We always have P and Q, and then they could both be true. First one could be true and false, or false and true, or false and false. Now, so right, let's say, okay, this is the club, right? So on the entrance of the club, there's this big sign saying if you're wearing a tie, then you are wearing smart shoes, and then you'll be allowed in, right? So let's say you arrive at the club, you're wearing a tie, so that's true. You're wearing smart shoes. Would you be allowed to go into the club? Yes, because you meet the rules, right? Because you're wearing a tie and you're wearing smart shoes, so clearly you're going to be allowed in. Okay, now let's say you rock up to the club and you've got a tie on, but you haven't got smart shoes on. Let's say you've got some sort of trainers or sandals or something like that. Would you be allowed access? No. Alright, because it says if you're wearing a tie, then you must be wearing smart shoes, right? Now here's where it gets a bit funny, and here's where, if this was a real life scenario, you could probably end up being beaten up by the bouncer or something like that. But let's say you arrive at the club and you're not wearing a tie. Okay? So this is false, you're not wearing a tie. But you're wearing smart shoes. Now, would you be allowed access to the club? Yes, you would be. It would be true. The reason for this is that because of this word if. Okay, let me highlight that in like blue or something. If. This thing is all about if you're wearing a tie. Okay, so if you're wearing a tie, then you must be wearing smart shoes. But if you're not wearing a tie, it doesn't really matter what shoes you got on. So you can argue that with the bouncer. You know, you could say to the bouncer, you know what, mate? If that's the rule of your club, then you know, I can go in if I'm not wearing a tie, and it doesn't matter. You could go barefooted. So that means this last bit here is also true. You should still be allowed access to the club because you're not wearing a tie, and this rule is all about whether you're wearing a tie or not, first of all, if you're wearing a tie. Okay, so if that kind of makes sense to you. So, you know, if you're wearing a tie, then you must be wearing smart shoes. So this case, you're wearing a tie, you got smart shoes on, you can go in. If you're wearing a tie, then and you haven't got smart shoes on, then sorry, you're not allowed in. But if you're not wearing a tie, then it doesn't matter what shoes you got on. You could go barefooted, really, according to this rule. So you can still go in, because the rule is all about whether you're wearing a tie or not first. Okay, now, the thing to remember, if that doesn't make sense to you, which, I mean, it doesn't make sense to everyone. I mean, that's the best example I can think of, really, regarding this. But if that doesn't make sense to you, the thing to remember is, if the first thing is true, then you need to look at the second column and see if that's true or false. However, if the antecedent is false, then forget about the rest, it's automatically true. Okay, so let me rub out this rubbish that I've kind of got here. Let me rub this out so I can explain that a little bit better, right? So if the antecedent is true, okay, so if the P implies Q is true, then you must look at the first column, the second column as well, and check if that's true, and then it's true. Okay. If the antecedent is true, then again check the second column, and if that's false, then that's false, right? If the antecedent is false, then don't even bother looking at this column. It's automatically true. So don't even bother looking at this one. If that thing, that first thing here is false, don't even bother looking at the column for that one. It's automatically true. Okay, so you can, if this example doesn't make sense, remember this. Okay, so the only time this thing is false is if the first thing is true and the second thing is false. So if the antecedent is true and the consequent is false, that's the only time ever when this column is false. Okay, so otherwise it's just true. So remember that. Okay, now I'm going to give you one more example without this sort of wording stuff involved, and one where it's just a truth table. So let's say you were asked to construct the truth table for P implies not Q, right? Okay, so first of all, give you the truth table. You got your P and your Q, and you got the true, 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 false, false, true, false, false. Okay. Now think about what you need to do here, right? So first of all, it's best to work out not Q first of all. So you want not Q first. So the opposite of this is true. Oh, sorry, hang on. Whoops. So that's false. Opposite of that is true. Opposite of that is false. Opposite of that is true. So you got false, true, false, false. So the opposite of this. Now you want to do P implies not Q. Now you need to think about what columns you're going to compare here. Now P is this column clearly, and the consequent this time is this column here. So you're looking at this with this. Now remember, this thing is only false when the antecedent is true and the consequent is false. Now this is true, this is false, so that's false. This is true, so that's true. Now remember, if the antecedent is false, don't even bother looking at this column. It's automatically true. And you're done. That's it. Okay, so that's the implication symbol done and dusted with. So you need to remember how to construct the truth table from it. So the only time that it's ever false is if that's true and that's false, otherwise it's true. And remember it as a sentence is if first statement, then second statement. Okay, so there's a couple of things you'll be asked to do, alright? So remember that. Okay, I'm going to